Hello everyone, welcome back. It's time for us to do more proc macros because I ran a poll and everyone wanted more proc macros, so that's what we'll do. I also ran a poll about whether people wanted to see chat in the video, and the consensus was that we should not have it. Keep in mind that if you are watching this sort of after the fact on YouTube, there's a link in the description below that links to the live version of the video, which will have the chat on that side, while you watch. And so that will be kind of neat. So before we get started on today's stream, I also want to point out that I tweeted this a few days ago that I used to have a Patreon for this work that I do and realized that I'm not allowed to have that in the US because I'm not allowed to have any source of income outside my studies. And that was a bummer, so I've been trying to find a way because a bunch of people have been asking me how they can sort of support my work, and so I've decided to set up an Amazon wish list where people can, like, if you want to, like, donate something to help make the stream better, you can do so. And I posted this a few days ago, and I've already been just overwhelmed with the responses. It's been really cool to see people just like strangers on the internet sharing things with me. And so to all of the people who have sent me things, thank you so much. I appreciate it a lot. It makes me, yeah, it's great. I very much appreciate it. And so there's a list where there's some small things and some large things. There's a bunch of D&D stuff because I like D&D. And so if you want to buy me stuff from this list, then that would make me very happy. If you can't, that's okay too. This is just the only way I could find where there's some way of showing support. But even just like your thank yous mean so much to me. I also want to remind you about the live coding voting site. So I'll post this link in the chat somehow. In fact, how will I even do that? I will do that this way, like so. So on the site, you can vote for upcoming stream ideas. My guess is this will be the last proc macro stream. And so the next stream, unless things change, is going to be a second open source contribution stream. We did one of these a while ago, and the idea here is basically I spend like the 5 hours or so that the stream goes for trying to contribute to a number of different open source Rust projects, and I'll sort of solicit opinions from you, the viewers, as to which projects we should contribute to. And it can be small contributions, large contributions, whatever we feel like we want to do. Usually what we'll do is try to find less developed projects and then look at issue trackers, for example, and then try to find a thing to contribute. Let's see, before we start. Okay, so there was a question here. Do you have any videos implementing event loop? So some of the future stuff is event loop based. So you could try that. I couldn't have a Patreon because I'm on a student visa in the US, and so I'm not legally allowed to have any source of income that is not basically my the assistantship that my university pays me. I'm not allowed to have any other source of income. Okay, so let's dive into procedural macros again. I'll try to get better at like reading chat aloud as well. So I'll be monitoring that in the background. So if you remember from last time, we started working on David Tolnay's procedural macro workshop from the Rust LATAM conference. And we basically did the very first exercise of deriving a builder pattern. So the way this looks is you want to have some kind of struct and you want to be able to put derive builder above it. And what our macro does is basically generate the code to have a builder for that thing. So if you remember back to, let's see if I can find this. Let's go with builder, just to sort of bring us back to where we were. 09? No. Let's do 08. Builder 08. No. Builder 07. Great. So the idea is that if you have some code that looks a little bit like this, So you have a struct with derived builder, and you have some fields with different types. You might even have things that are vectors, for example, where you want a builder to have a builder argument that just gives you a singular thing. Then that should give you a builder type that you can then use this stuff on. And so to remember, the procedural macros basically take as input. Oh, what did I do? I did a stupid, did I? The procedural macros basically take this program as an input, sort of a stream over the tokens of this program as an input, the things that have been annotated with derived builder, and then produces a stream that adds new tokens to the stream. So what that means is it basically expands the program. So in this case, cargo expand shows us the expanded version. So here we have the command that was in the original source. Remember, the derived builder attribute has now been removed because it's already been parsed. And what we generate is a new struct command builder with the same fields, a bunch of methods on that builder, and a build method that produces the final command. And so what this means is ultimately this generates all the code that's necessary to make the operations that the user gave us work out. So the question is, if we go back to our list here, the question is what exercise do we want to do next? My hope is that we might be able to do maybe 2 in the 5 hours we have, given that the first one basically taught us a lot of the concepts that we're going to need in order to do these. And then the other ones are sort of expansions upon those topics. So let's do a quick straw poll in chat here. Let me first briefly go through the options. So there's derived custom debug. So the idea here is that you know how you can have derived debug on a struct? Custom debug is going to also let you define how you want different fields to be debug printed. So in this case, this would say print the bit mask using this format. So that would be one macro we could implement. Another is seek. So the idea of this macro is that you can give the seek macro followed by basically an iterator, and then a segment of Rust code that will be where we're going to look for this pattern, this like pound open bracket, similar to like in macro rules. And what's inside there will be expanded n times, where n is the iterator, with pound n replaced with the value of the iterator. Right? So this would generate like CPU 0, CPU 1, CPU 2, CPU 3, etc. All of them as variants of processor. But it doesn't have to be inside of an enum. It could be all sorts of different things. Pound sorted is going to be a compile time assertion that the variants of an enum are ordered. And so if you put pound sorted on an enum, then if the enum variants are not sorted, it will be a compile time error. Bit field is, I see. You basically define how many bits each field takes up, and then the attribute lets you access those fields and set those fields appropriately, and make sure to store them using whatever the appropriate integer type is. And my guess is that the bit fields one is probably a decent amount more complicated. So looking at the project recommendations here from David, custom debug is going to look at trait bounds. Seek is for custom syntax, right? So normally we've been using the syn crate for parsing out Rust syntax. In the case of seek, we're going to have to basically walk the syntax tree to find places where we need to replace the main variable, right? So this is basically like custom syntax parsing. Sorted is mainly for looking at how to get good diagnostics from a macro. And bitfield, yeah, so bitfield do only when you have a strong grasp of at least 2 other projects. So I think we might do bitfield today, but we should not do it first. And so I think the options are, do we want to do sorted, do we want to do seek, or do we want to do derived custom debug? All right, so votes. Who thinks we should do which? Specifically, out of these three and not bit fields. We might do bit fields after, but I think we should do at least one more to like get back into the groove of things. So there's seek. Seek is probably rather pronounced like sack than seek. Sec? Maybe. So the reason I pronounce it seek is because it's sequence, right? Seek, sequence. It's not sequence, right? Or sequence. But I don't know. Sorted looks nice and easy. Custom debug, sorted, seek. Okay. It looks like there's sort of a tie between sorted and seek. Maybe? I think seek looks like the contender here. Okay, so let's go for seek first, and then we can always do the others later. I agree that sorted is probably easier, right? Because it's only like enum variants and checking whether they're sorted. All right, so let's get started with seek. Function like macro seek. So the idea here is we're going to be given sequence. We're going to define a function like macro seek, right? And it's going to have the format like this. This is going to have to require numbers. Stamping out sequentially indexed copies of an arbitrary chunk of code. All right. So great. So we're going to have to parse basically this followed by an identifier, the keyword in, a numeric range, curly brackets, and then just regular code. And then inside of that code segment, we're going to have to look for this. So let's see how we might do that. So the syncrate, if I remember from last time, has a visit thing, which is basically a way to walk a syntax tree. And in this case, we want to mutate the syntax tree, right? Actually, unclear. Is that what we want to do? I think that's what we want to do. Because we want to replace the occurrence of this with the expansion of it, right? So visit mute. So I think the idea here is visit mute. This is not at all documented. That's potentially unhelpful. I wonder how we're supposed to use this. So does it say visit anywhere else here? Not really. Actually, maybe visit is documented and visit mute is not. Let's take a look at visit. That seems relatively unhelpful. Is there a visit token stream maybe? Like a top level entry point? Are there provided methods for this? Where? Oh yeah, that's a good point. All of these things from the workshop are actually, there are real implementations available of them. I don't know where they're linked. I think if you read this more carefully than I did, basically all of these exercises, there's a crate on crates.io by David that implements this feature. And the real question is, where is like the top level entry point? Where do we start? Is there there's no like, is there a token tree? No. Interesting. Oh, maybe there's a parse, a variant of parse that takes visit. Parsing a custom syntax. Lazy static example. Great. Let's take a look at that. Implement parse. Well, we don't want syntax that's... Actually, this might be useful for parsing the... this might be useful for parsing the top level thing, right? So... why is it not giving me the seek? For parsing this business, right? That business is sort of like lazy static in that we'll want to parse a particular sequence of tokens. Okay, so that works decently well. Getting error messages, that's fine. The real question though is, this still doesn't really give us the visit pattern. I'm like fairly convinced we want the visit pattern, but the question is, how do we start parsing that way? Actually, I wonder whether this would let us parse module. Maybe something in here takes visit. Parser trait. Parser. No, this all seems to just be to turn token streams into parse streams. Wonder, here's what we'll do. Repositories. Fold, visit, mute. Is there a fold in there? So for, I guess, visit, mute. Do you see a fold? I did not see a fold. I guess this is a top level fold to transform the nodes of an owned syntax tree. Oh, interesting. As a fold might even be better. Yeah, you're right. I think fold might be better because that really is what we want to do. We want to walk the input, transform it, and produce an output. But it sort of has the same problem in that these aren't really documented. Like, none of these give me an example of what they do, although the function type sort of helps. Fold macro. Specifically, the question is, what is like the top level function I call to fold over a stream? QSelf. So what I wanted to do is look at this and see how this does it. So here, okay, a bunch of documentation, that's fine. Right, so this is parsing that. This is basically the same code we're going to end up writing. Expand repetition, this is really what we want to see. Yeah, so the body here is the token stream, right? The token stream is sort of what we care about. And oh, interesting. So this doesn't actually use the visitor pattern, which is surprising to me. Instead, it just walks the groups. So if it's a group, then it does that. Huh, interesting. I guess what we're really going to need here is proc macro 2. So remember, proc macro 2 is the crate that gives us access to the procedural macros in the compiler in like a way that's independent of the current compiler version. And the token stream, it basically gives us an iterator. Where's the here? An iterator over token trees that are either groups, idents, puncts, or literals. Okay, well, in that case, I'm very surprised we can't use fold here. I feel like we probably can. The biggest problem is that fold isn't really documented. I wonder whether the trace var example uses fold. Oh, nice. Okay, let's try that then. Trace var. Source. Let's see here. Fold. Oh, is like expression the top level thing? As item fn. I think the real question is, what do we parse it as? Parse macro into args as r. Okay, so that's fine. This is to parse. If we go back here, okay, so this macro is an attribute always on a function, and so that's a little different because okay, so it parses the input, like the body that it's given, as an item, or specifically a function item. It parses the arguments of the macro as args, so that's reasonable, and then just fold item fn. The problem we have in our case is really that for, if we go back here, we don't really know what type is going to be here. It can be anything, right? It's like any token stream, which is why we don't actually know where to start the fold. Maybe we know it's a block, or we know it's an item. I wonder if there's a general like fold item. Ah, fold item. That might work. An item is an external create, a use, a static, a constant, fn, mod, existential structs. No, because it doesn't have to be an item either. Like our problem here is this could be anything, right? Like the stuff that follows C could be just a sequence of tuples that it gives an example of here, right? It could be an expression. It could really be anything. And it looks like fold doesn't have an entry for anything. Like what I really want is like a fold, but I don't think there's just a fold. So it seems like we might actually have to just walk the token stream ourselves. It's a little unfortunate, but we can do it. Okay, so we're gonna start with, where's our, no longer in builder, we're gonna be in seek. So we're gonna be in seek, and nope, here, this is still gonna be cargo expand. And here, test 0 parse headers. Great. What I want is just for us to have something to start with for our main, so that which we can use cargo expand with, right? So if I go here, now run. Actually, let's make this be in seek and this be in here. So cargo expand currently just crashes because we haven't implemented the macro, but now at least we'll be able to. There's something you want is called a token tree. Yeah, I know that it's a token tree, but there is no fold token tree. Okay, so what we're gonna do is we have to start implementing this thing in the first place. So seek source lib. Right, so now we're at the point where we know we defined a proc macro, right? It's not a proc macro derived like we wrote last time. This time it's a proc macro which defines a sort of a similar thing to what you get with macro rules, like a macro you can call. And so that's what the proc macro attribute here tells the compiler, is that what we're defining is a function like proc macro. And what that is given is it's given an input token stream, and it has to return a token stream that's going to replace the current item. So if you remember from the last stream, a proc macro derive appends to the token stream. It's not allowed to modify. Well, I don't think it's allowed to modify the input, but it produces a new input, like appended input. So won't seek 0, 1 million be horrible for compile times? Well, so it's true that if you were to repeat a particular thing a million times, you're basically expanding the source of your program a million times. So yes, it would be terrible. But then again, that's what the user asked you to do, right? Okay, so we know from last time that what we want to do here is parse the input to the macro, right? So if you remember in Sin, there's this handy dandy macro called parse macro input, right? So if we here use Sin parse macro input, then here what we want to do is parse macro input of, remember how the syntax is the identifier as the type, right? In our case, we're taking the input and we want to parse it as, so remember last time we used derive input, right? This time that's not actually what we want. This time we want, where's the, oh, maybe the default is just what we want. So what does it say here? As my macro input. Oh, interesting. Actually, that is what we want to do. In fact, this is exactly what we want to do, right? We want to parse it. The input to our macro is going to be some custom syntax. And so, sure, we're going to do this. Although it's not quite, we're going to give it a better name than that. But first of all, we're going to have to just like make it not crash, right? So here we're going to return a token stream new. So the macro is going to expand to nothing currently. We're going to parse it, print it, and then expand it to nothing. And in our case, I guess here we're going to have to do this business. So this is going to be a seek macro input. Seek macro input. We're going to parse the input we get as a seek macro input. And here, this is going to return OK seek macro input. Let's see what that does. Oh, do I actually need to do this? Oh, right. I haven't even defined these. Dependencies. I want, oops, no. I want dependencies to be seek 015 and also quote 06. Oh, I meant Sin. And here we want to derive debug. Great. Unexpected token, huh? Oh, I see. Because now we're not actually consuming the input. And so it thinks that the macro basically starts parsing here. And then it consumes no tokens, right? Because our parser does nothing. And so it then says, okay, I'm done. And then the compiler encounters this token as like, I did not expect there to be a token here. The macro said it was done parsing, but it hasn't moved along in the input stream. And so what we need to do here is basically the same thing we thought we saw earlier, right? We want to basically parse the custom syntax that we're expecting. So if we go back to here, we basically need to parse out this business, right? And so what that's going to use is, if we look at the parse module, it basically provides a number of parse functions. I don't actually need look ahead for this. What was that? There's a nicer... parser. Yeah. So you basically give... Oh, I see how they've done it. That's interesting. So there's parser and parse. How are they different? Oh, we might need the parser module. It might not be on by default. Yeah, so parse is anything that can be parsed in a default way from a token stream, right? So we're going to have to say something like, if we expect the next thing to be a literal, for example, then if I understand this correctly, it's going to be something like the variable we want is going to be... actually, no, it's not going to be token. I guess the first thing we're expecting is an identifier for the variable name, the n, right? So it's going to be syn ident parse input. Let's see what that var is. Hopefully this should print n. Let's see what it gives. Yeah, so this gives us an ident, n, and it shows the span, remember from last time, which tells it where in the original source that ident appeared, right? Oh, right, parser, you're right. Parse is what we implement, but I was wondering what parser is, because all of these use parse, but I don't think it's important. Right, so if you look at the syntax we're expecting, we want n, we want the literal token in, then we want these things. So next question becomes, how do we get a keyword like in? From memory, there's a token thing. Let's see if I can find this somewhere. Is it macro? Token. Yeah. So I think this is what we want. So here, let's bring in token as well. So in is going to be token in parse input. And I guess we can print that out too, although this one is less important, right? We don't actually care about the value of in, we just care that there is an in there. Sorry, I meant colon. Ooh, that might not work. Yeah, although that's not actually what we want either. Interesting. Because token in gives me a, I'm guessing like syn token. Like it is basically a Rust keyword, right? So it gives me a concrete one, so I don't know how to call parse on that. Oh, it's probably something like this. Is input.parse. Not sure, but... Oh, is that what you wrote? Oh, nice. Great. Right, because token in gives me a type. Although that should then still work, actually. If it gives me a type, then this should be the same. But the compiler might not be able to figure out. Yeah. But if we do this, I think that should be the same. Basically telling it this is a type, call this associated function. Great, that's the same. Perfect. So the in, if you look at it, just parse to in, right? It's just a keyword. We don't actually care about the value, which is why I use the underscore so that the compiler won't warn us about unused variable. All right, so the next thing we're expecting is we want a literal followed by 2 dots followed by 512. Okay, so we're going to have, I guess, from, it's going to be a literal parse. 2 is going to be a literal parse. And in between, we're going to have dots, double dots. Oh, and I guess I want to print out, in fact, let's just keep all of these in one. So var in from dots to. Did I miss any? I think that's right. Right, so we get the ident n, right? We get the in keyword. We get a literal number 0. Then we got dot2, right? So dot 2, that is a double dot, which is a literal. Then we got the literal number 8, and that's what we parsed. And then it's saying unexpected token for the curly brackets. And so now what we want is the next thing that's going to come is basically a block, right? So the question is, how do we parse a block? What is the type for a block? Which, let's look at our parse here. Actually, this might tell us the type we're going to use for fold. Whatever we parse here, actually the body is just going to be a token stream, right? The next thing now is just a token stream of some kind. But is there a way for me to say like curly brackets? So use tree is not what we want. Expr block. It's not really necessarily an expr block. I wonder whether it'll let me. It's really almost like a module block. Like an item block, is that a thing? No. Item mod, maybe. No, because that needs to include the name. So what's the content? It's a tuple of brace and a vector of items. Oh, interesting. You could probably also parse as an expr range. So the reason I don't want to parse it as an expr range is because we're going to have to iterate over this range. And I probably don't want to allow, I don't necessarily want to be able to support any range. Although, you're right. I mean, we could just assert that it's a particular type of one. So what does expr range parse? Okay, any of these. Yeah, but like, okay, so imagine that I got this back, right? That's not a useful construct for Seek. It can't generate an infinite number of things. We don't really have iterators here. We're going to copy the same thing multiple times. The one thing that might be nice is that we get this, but I don't think it's terribly important. There's an impl parse for block. Yeah, but I think a block is like an expr block. I mean, what is a block? A braced block containing Rust statements. No, you're right. That looks perfect. I agree with you. Okay, so the next thing we're going to have is body, which is going to be syn block this. But that is not an input to fold, which is weird. What? Oh, I need the full feature. Okay, fine. So version is this, features is full. And then you can continue with sub input. Wouldn't block have to be completely valid syntax though? Oh, that's a good point. Block might actually parse. No, I think what. That's a good question. No, I think it just parses it as syntax. And like, remember, a macro invocation is also valid syntax, right? I guess actually we're going to find out. Okay, so we now pass. My guess is we pass test 1. Oh, what was the RS progress. Great. So we're now going to pass the first test. We should pass without a problem because we don't crash. You need syn braced. Ooh. What? Oh, do I need to explicitly enumerate all of them? Oh man, why? What are the default features? I see. So what I want here is just like all features, but let's do full. Wait, what? Why does it work in cargo expand but not in cargo test? Oh, extra traits. But why? But why does it extra traits? I wonder why it works in cargo expand. That's weird. Oh, cargo expand probably also relies on syn with that feature added, is why. So what cargo does when it builds something, if it finds one dependencies and multiple parts of the dependency graph that have the same version, it takes the union of the features for it. And so if cargo expand builds with a dependency on syn with extra traits turned on, which it might very well do, then it will also compile the underlying crate with that feature on, which is why this compiled fine, and also why this was not working. Great, so we now passed test 1, so let's go to test 2. I guess progress. Let's do 2. Okay, so this... What does this expand to? Okay, so I'm guessing this won't actually pass. Wait, what? Oh, interesting. The macro invocation of the previous test case contained an empty loop body inside the brace. In reality, we want for the macro to accept arbitrary tokens inside the braces. Callers should be free to write whatever they want inside the braces. The seek macro won't care whether they write a statement or a function or a struct or whatever else. So we'll work with the loop body as a token stream rather than a syntax tree. Yeah, so this is what was pointed out elsewhere, that that what we might want is to not even parse it as a block, but just as a brace. Like, just, it is contained in braces, but we don't actually want to parse the thing inside yet. Although that still means we can't do it with fold, which is a little sad. So if I go to lib here, so instead of this, what's the, if we go to here, braced. Interesting. Content in input. What is that? What does this do? Why does it need this in syntax? That's interesting. Content. Brace token is of type token brace. So why does it need braced? That's super weird. Oh, I see. It just consumes the braces. But why is the let content necessary? Like specifically, is it fine for us to do like let braces is syn, where's token, like token brace, parse input? Like, is that a thing that it's going to be okay with? Right, I'm guessing why doesn't it just expand to its own value? The real content. Can a file body, what did I do? Oh, this business. Okay, so brace can't be parsed. So it's really, that's so weird. I don't understand why it has to be called this way. Braces, input as content, content as input. Like, why is that necessary? I guess this is braces. Oh, the content is the stuff that's inside. Never mind. But I still don't see why it can't be this, right? This is what I really want. Oh, because you also need the braces. Okay. Oh man, that's funky is what that is. Okay, so this returns the braces, and I have to write this to say I want the content to be placed in that variable. Oh, that's awful, but I see why it's needed. Specifically, the problem here is braces really needs to do two things. It needs to give you a handle to the content inside the braces, and it needs to give you a handle to the braces themselves, so you can replicate them if you need to. This means that it needs to return a value, right? So one of those can be returned, but both can't be. Well, it could return a tuple, I guess. Actually, wouldn't that be nicer? Wouldn't it be nicer if this just returned a tuple of braces and content? Oh, right. Oh well, okay, so this means that the content is the stuff that's going to be inside the braces. Braced? Question mark operator cannot be used here. Wait, really? That's fascinating. What if there aren't braces there? Why doesn't this return an error? Right. Okay, so now we're not currently parsing the token stream inside. I guess, how do can I just say that I want to consume a token stream? Proc macro 2. If I have a token stream, I guess I could just walk the entire thing. Oh, I see braced contains a return statement. That also seems weird, but okay. Right, so the real question is, what is the stuff that is inside of the content, so inside the braces? Well, I think what we want here is, right, so the content expands to a token stream that's going to have whatever kind of syntax in it. So here, what I think I want us to do is just for in content. Parse buffer. Oh, right. That's what braces give us. So if we look at, it gives us a parsed stream, not a token tree. So if I go here, go to parser, is this where parse stream is? Parse buffer. Right, a cursor position within a buffered token stream. Yeah, so okay, the content is now input. I agree. I understand the setup. The point now is content. So the error we're now getting is in parsing. We're currently looking at over here, right? This is the current file we're trying to work on, and currently what we've done is we've parsed everything up to the curly this curly bracket. And this inside here is still a token stream that we're not consuming anything of. And this is really what content points to, what I've just highlighted. That's what the content variable is, a parse stream over that content. But currently we're not consuming any of it, so our parsing basically stops here. And when our parsing stops there, the compiler then says up here, unexpected token, expand to nothing, right? Because we haven't told it that it should expect to parse that out. And so one thing we could do here, of course, is we could just do like while, is there like an is empty? Yeah, okay, so while not content is empty, and then like, yeah. Although, will this even, I don't know what this will give us. I guess let's see. Yeah, the problem is we have to actually say what we want to parse it as, right? Oh, someone suggested the same thing. Nice. Yeah, Felix, I think, no, it's super helpful what you do. It's more like, I end up thinking through the same thing as you do while you type it. Although it is useful to have someone else who knows this during the stream. So let's see. The real annoyance here is that we don't know what to parse this as. We sort of really just want it as a token tree. Actually, let's take a look. What did the over here? Yeah. Because in David's version, he keeps it as a token stream, which seems like the sort of right thing to do. That's sort of what we want too. Oh, that's funny. Yeah, so he parses out a potential equals there. Require braces. So this seems to be much lower level. Does he even use syn for this? Oh, he just parses it manually. He doesn't even use the syn crate for this. So that's part of the reason why this gets complicated. Whereas we're trying to use it with the syn crate. So what does he require braces? Where does require braces come from? Crate parse. Parse. Require braces. I see. Yeah, this is why we might not want to use the this is why we might not want to use the syn parser for this, because here what we really want to do is just get the raw contents within the braces, unless we can go from a parse stream to a token stream, right? Like for parse, where did I have parse open here? Oh, yeah. So what we can do here is actually just something like let token tree is going to be proc macro token tree parse input content. Let's see what it does with that. Which token tree is this? Oh, proc macro 2, right? And I need to also depend on proc macro 2, which is what version? Proc macro 2 is version 0.4. Expected reference. Really? Well, apparently. But it can't be a token tree either. Token stream. Right, because a token tree is just a single... it's not quite a single token, but it's like... it's basically one subtree of the AST. So if you look at the error we got was unexpected token was now exclamation mark. And that's because this is an ident. So this is an AST in and of itself. This is a separate part of the... it's basically the next token, right? This would be one token. It would be a group that's delimited by brackets. And so if we park it as a token tree, all we're really parsing is this. If we parse a token stream, that should be all of these, basically all the stuff that's in content. So I think token stream is going to give us the right thing here. Great. Right, so this parses out, this gives us back a token stream that is the entire body of the thing. Oh yeah, see? Same thing. Nice. Right, so we don't really need content because it's going to be the same as this token stream. Now the question is what we do. So one way to do this is now just to sort of walk down into this tree until we find a relevant thing, right? So this now already parses everything. So we don't really need, we now already consume the content. So that's all fine. Consider, right, we're going to need the 2. That's fine. Great. So now we should pass 0 and 2, sorry, 1 and 2. So the next question is going to be for progress 3. So the next one, now construct the generated code. Produce the output token stream by repeating the loop body the correct number of times as specified. Okay, so this is going to be basically now we're going to have to start to actually do the real code generation. Repeating the loop body the correct number of times to specify the loop bounds and replacing the specified identifier within the loop counter. The invocation will need to expand to a token stream containing, yeah, so this 4 times with n being 0, 1, 2, 3. Great. Okay, so what this is going to mean is we're going to have to walk the token tree. So let's do the same thing we did before. So we're going to stick this into main so that we have a good way to see what it expands to. And the cargo expand now is going to expand to nothing, right? The input code that we gave, this seek, if we look at the expanded output, it's not there. And that is because the output token stream we produce is empty. And that's, of course, not what we want it to be. So here, what we're really going to have to do is... interesting. So we're going to have to walk down the token stream until we find somewhere that is the variable. Interesting. So we're basically recursing down into this is where it would be really nice to have something like fold. But of course, the problem is we don't have a top level fold. Let's take one more look at fold. It would be really nice if we could use fold for this. Fold. Ooh, X. What does X do? It's not what we want. Yeah, we just like have no idea. I mean, there's fold block. I wonder whether I wonder whether we can get away with parsing this as a block. And then just walking the block instead. But it might not matter. Okay, so we're going to do... for I in to from. No. What am I doing? From to 2. No, it's not a block. Yeah, I worry that, well, currently it is a block, but it's like a general type of block. It's not an expression block, right? So I think it is a block, it's just not an expression block. The real problem is whether it will allow us to also get at macro syntax deeper in the token tree. So I think we might just have to do this manually. So So we're gonna do expand TT with I. We're also going to SynBlock is a valid Rust block. Yeah, if a SynBlock requires that it's a valid SynBlock, it wouldn't be. Actually, let's do this for now. I'll not preempt myself. So expand is going to take a proc macro to token stream and is going to produce the same thing. So it's going to get stream, probably clone, and it's also going to have to take an I. Might not. No, it does need to return the token stream, but it might not need the question mark. And here, what we want to do is interesting. We need a way to basically construct up the output we're going to get. So I think what we want here is let expanded is from to map I to this collect. And then we are going to well, so actually, really what we should do here is, at this point, we've already parsed out all that we need. So really, we should sort of stick that into here and then implement, essentially implement print for sec macro input. It's not really print, it's like into token stream, right? So really what we want to here is impl into token stream for sec macro input. Right, so this is going to have the fields from, which is a usize, to, which, actually, let's make it iSize. We don't know if they're negative. And token tree. It's going to be a proc macro to token stream. Right, so at this point, we can do sec macro input and we can produce this thing. At this point, we're kind of done parsing. It really depends on how we want to define parsing. I don't think we want to parse any more than this. So from to TT. And then it's only really at here when you want to turn it into a token stream that we want to do the expansion. You can pick stuff from sec macro input inside the sec function. Not sure what you mean by that. But regardless, this, I think now in theory we should be able to do input.into instead of that. This is going to expand those. Yeah, I mean, that was basically my plan was to now do this, right? Quote of, although I sort of want, we also need to use quote. I basically want this to be is there a way I can iterate in quote? I forget. It might be that the way we have to do this is out is going to be an empty I guess a token, a proc macro 2 token stream empty, and then this doesn't need to collect. We just do for I in this, and then we do out is quote. Oh man, I forget from our other one. Pound is what it is. Expanded is expand tt dot self dot tt dot clone I, and then this is going to be out and expanded, and then we're going to produce out. Simpler. Parse to quote quote. I don't see how that helps. Okay, so this is going to basically keep appending to the token stream what we get from the expansion, and then eventually return when they've all been expanded. So now the trick is going to be to implement this, right? And here, this is where we're going to have to recurse into the sort of depth of the token stream. And I think we're basically going to end up with sort of an expand inner that's going to be expanding token trees instead. Because I think what this is ultimately going to be is it is just going to walk the elements of the token stream. So while actually, let's take a look back at token stream. Token stream. So token stream implements into iterator. So I think what we're going to do is just walk the walk this iterator, and for each thing, basically look for the identifier that we know we're looking for. Oh wait, that's also true. I need the identifier in here. The ident, which is going to be a syn ident. So this is also going to have ident. Let's call this ident, because that's what it is. So we're going to do stream dot into iter map. This is going to be for each token tree, we're going to do some expansion, and then we're going to collect it into a token stream again. Because that implements from iterator token tree, right? So we're gonna walk every token tree we find and see whether we need to expand it. And here, I think really what we're gonna need here is something like expand 2 for now. It's going to take a token tree and it's going to produce a token tree. Token tree. And it's going to match on the TT. And if it gets a proc macro 2 token tree. So what are the different candidates here? So the candidates are group, ident, punct, and literal. So if it gets a group, then it might have to do something. It has to recurse into the group. What is a group here? Right. And if it's anything else, then it can just return that token tree. If it's a group, internally contains a token stream which is surrounded by delimiters. Right. So here, really what's going to happen is we're going to have to do proc macro 2 group. We're going to have to do this. Right. It's going to produce a new one with the same delimiter as the old one and the adapted token stream. This is going to be expand So this is calling the stream expand of the group stream, and still the same I. G. And we probably also want to do set span is going to be G span. So this is going to be the expanded. So this is going to produce this of expanded. Right? So this is going to map a group into us expanding the stuff inside the group. And expand is just going to call expand2. I guess actually it might have to do this. Expand2 of the TT with the given I. Now this isn't quite true, right? We know that if we encounter the identifier that we care about, the variable, right? Then we actually do want to expand that differently. So in particular here, if we encounter an ident, an I, where it is item we want, right? Ident. Probably ident we want. And if that I wonder if that I is equal to, oh, so this is still going to have to take self. And this is going to have to take self, which means they're going to have to be moved into impl seek macro input. This is going to be self.expand. Right, if the I is equal to the identifier that we were given by the user, then we do something. Specifically, then we expand it to, then it's going to become a proc macro 2 token tree literal instead. And specifically, it's going to become a literal that's going to be the current I. I guess I here is going to be an I size, we decided. And that literal, I think there's like synlit from I. Although I think we want to make sure that we keep the right span here. So the lit is going to be this. So this is the literal we're inserting in place of the identifier in the stream, and I think we want to set span I.span to make sure that if there's an error with this literal, it is tied back to the identifier in the original input, and then we give this as lit. All right. Let's see what this gives us. This is probably all sorts of broken. Yep, that was broken. That is totally true. We're going to have to do... Wait. Up here. Self.from, self.to, self.expand. Love your Vim setup. Got your config somewhere. Yeah, there's a video in the... If you look at the YouTube channel, if you look at my YouTube channel, there's a video on my editor setup and stuff. So if you're interested, you can go look there. I've made some changes since then, so arguably I should do another one, but it should be there. Ooh, you're right. These are not iSize. These are syn literal. Which is kind of awkward, right? Like, we actually want to require that they're integers. So I think specifically, I want this to be a lit int. Is there a, is this implemented for lit int? Great. So this is going to be a lit int. This is going to be parsed as a lit int. And this is going to be parsed as a lit int. Now we would probably need this here as well. Still probably going to complain that they're not numbers. 44 is going to be new. So 45 lit int dot value. Oh, is there a lit u? Oh, interesting. That's surprising that this is only a U64. It doesn't take a signed integer. Well then. Okay, I guess it's gonna be a U size. Actually, yeah, no, it's gonna be U64. Fine. It's surprising. I don't know why it requires a U64. Mismatch types. Expected token stream. Dot into. Right. This is needs to become. So this is a token stream from proc macro 2. And we need to turn it into the actual type that the compiler expects, which is from just a proc macro crate. Here, from syn ident. Oh, I'm shadowing the I, aren't I? Ident. If ident, ident, ident. Because -123 is 2 tokens. Oh. That's awkward. Yeah, you're right. The signed integers are modeled as separate AST involving unary minus. Yeah, this might be a good reason for why to parse it as a range. We talked about this a little bit earlier, but it could totally be that we want to use expr range here because limits. Oh, that's the stuff in between. From and to are both. Why are they box expressions? Right, this is the reason why expr range would be annoying, because I guess we would have to check that the exprs are the right type. So what is if an expr lit is a lit is a wait, that doesn't seem right either. Oh, it would be a unary expression. I see. Yes, we would actually have to parse it. We would have to walk it all the way down to figure out what it is. So even expr range wouldn't really help us here. Okay, that's fine. How about now? 63. Sorry, you're right. This should say I. That was the whole point in the first place. From U64 is not implemented for synlit. Really? Maybe like that? Do I really have to expected struct int? What does, am I missing something here? Synlit int. Oh, I actually need to do new. Fine. And that gives me a lit int. Okay, so this is gonna be new. It's gonna take the I. It's gonna take a suffix, which is gonna be none, I guess. And it's gonna take a span, which is gonna be the span from the ident. Wow, I can't type today either. Which now means we don't need this or that, and also means we can do this. Let's see what that becomes. Mismatch types, expected proc macro to literal. Oh. So this presumably there's a, yeah, so lit implements, I assume this implements from lit int, and I assume it implements 2 tokens. It does. Great. So here I could use quote, but I probably also need, maybe I can just do into here actually, come to think of it. Really? I can't turn this into a token tree literal. So there's a token tree literal. That's surprising. I mean, I guess I could just construct this instead. I don't need to go through sin for this. So I could here instead just do, basically go back to this and say the lit is going to be not this, but proc macro to literal U64 unsuffixed. Or or sin to parse quote. Yeah, I mean, not clear that's even the right thing. It wouldn't give me the span. I would still have to set the span manually. Man, why is this? Like, really what I want is just this. But this won't work because literal needs to contain a proc macro literal, not a sin literal. There's a macro for that coming. Oh, for setting the span? Oh, quote spanned. Yeah. I see. So your proposal here is really that this just becomes sin parse 2. Can I make it just? Okay, parse 2 of quote spanned of span ident. And then, oh, isn't this quote span does some like funky syntax so that it's clear where the span is. I can never remember what it is though. No, sorry, quote spanned. Right, it specifically requires the white space to be like this. So this span 2. Oh, this is the name of it. So this would be like ident. And then here, I guess it would just be pound I. Right? What am I missing? And this. Or on one line with... Oh, I see. Or I can just do this. That's fine. Still not going to be right, though. I want quote, and I want quote spanned. Actually, is this quote going to just erase all of my... It is, isn't it? I think we're going to have to be a little bit clever here, which is... This is going to be this dot map this dot collect. I this collect into, where this is going to be a proc macro 2 token stream. Oh, I see. And this parse2 doesn't know that this is basically required to be valid syntax. So here we can unwrap. Quote, doesn't require it, but it prefers. Oh, one line. Yeah. You can make a vec of syn types and work with that. I don't actually need the vec of syntax, though. I think this this collect is fine. The real question, though, is punt ops range. Well, that's not right. This needs to be this, first of all. This is now a ref. Can't compare syn ident with this, so this has to be that. Ooh. Wait, that's pretty nice. That looks awfully correct. Right? Error number 0, error number 1, error number 2, error number 3. So I think it generated all of these correctly. Ooh. You don't think we need the into? I don't think this would work because expand returns. We would have to make expand not return a proc macro 2 token stream. I don't think that will work. Yeah, because expand. Yeah, we want that to return 2 so that we can use it in here, which means that up here, well, I guess we could up here do into. Oops, here, dot into. Unclear that the two matter, but then this could be proc macro token tree. No, token stream, and then this can collect into that. Am I confused? This should return this, and now into. So like, it's not clear to me that that's all that much nicer. Oh, I suppose I could just make all of, you're right, this could just be proc macro 2 token stream, proc macro 2 token stream, get rid of this, get rid of this, get rid of the into, just collect into a proc macro 2, and then only at the end here. The problem is this now is going to be dot into, right? It's going to be proc macro 2 stream, token stream from this dot into. Which is a little awkward, is all. Huh? Oh, that's annoying. To token stream from input.into. Problem is the compiler is not going to be able to resolve these types for us. So I think it's going to mean that I have to do something like proc macro 2 token stream is input.into, and then like output dot into here to turn the proc macro 2 token stream into a proc macro 1 token stream. But it'll still work. All right, so let's see if we pass the test now. No, we did not pass the test. We also now have an unused import here. What is it complaining about? 1 of 3 tests failed. So it expected the output. Oh, it's because I also print the stuff at the top. Let's get rid of these. Don't actually need these anymore. May end up needing this later. No. Oops, that's not what I meant to do. Seek cargo T. So what is it complaining about now? It's complaining about the suffix. Yeah, see, this is the reason why I kind of wanted to construct this manually, because this, I think quote always puts the suffix for integers because it knows the type of the input. Yeah. I don't think that's going to work. I think we're going to have to construct it manually. Specifically if it wants it to be unsuffixed, right? Here it says now error number 2U64, right? Which is not what we want. So we're going to have to go back to what we had, which is lit is... actually, can I can't really construct that with an unknown, can I? I think what I need to do here is just construct this. Macro 2 literal U64 unsuffixed I lit set span ident.span and then do this. Yep. And now I don't need code expand either. Don't need, oops. Great. Okay, so that gives us what we wanted. Why is it still printing stuff out? Great, so now we passed the first 3. So let's look at progress. Number 4. Paste ident. One of the big things calls will want to do with the sequential indices is use them as part of an identifier, like F0, F1, F2. Implement some logic to paste together any ident followed by pound followed by our loop variable into a single concatenated identifier. Optionally, also support more flexible arrangements like F pound n pound underscore suffix. I see. So the idea here is that you might want to use pound n as a thing that appears in an identifier, and then we want to put together those identifiers. Okay, so this one shouldn't be too hard for us, right? Because we already have this expansion business. And so here what we're saying is if the identifier is just straight up the same as the identifier, we're going to make it n. If we find another identifier where I guess we're going to have to manage identifiers especially here. So here we're going to search for pound ident followed by self ident, or pound self ident pound for myself followed by n at the end of an identifier, or pound self-ident pound. Okay, so if, I guess what we'll really do here is look at the ident name and then look for any occurrence of pound and see what follows it. So here, if we have an ident, what do we get from that? Ident. There's a thing here to get impl display. Really? Is there no way to get the identifier itself? It's unhelpful. I really can't get the string of an identifier. That's awkward. Can I get one with like a sin ident maybe? Probably. Ident. Ident ext. That's not very helpful. Is it really not? Is there really not a... through the toString method. Why is that not listed here? Am I just like blind? This doesn't say that it implements toString, but okay, great. So toString. I mean, you can always format it with display, but you know. All right, so yeah, but does implement display doesn't give you toString, does it? Or am I misremembering? Yeah. Or maybe there's a blanket implementation of toString for anything that implements display. Ident.toString. Name. All right, so we're gonna look for where's my down here somewhere. Specifically, what I want to do is split. Parts is name.split on pound. For part in parts. Actually, if parts dot any, actually I is parts dot position. No, string. Where the string is equal to self.ident. Unclear that will work. I guess it depends whether there's a partial eq for string. Because there might be. So if let sum I. Let's do a collect here. So in that case, we're done. If it's sum, we need to implement. You need to peek ahead. Ident pound. Ident. Oh, because pound wouldn't be a part of the ident. Oh, you're right. That's kind of awkward. I hadn't thought of that. So specifically, the observation is that if you have something like foo pound n, pound bar, right? This won't show up as an ident. What I was thinking here was I thought this would show up as an ident that's this, right? Where that is the ident, but that's not true. It's going to show up as foo followed by pound, followed by n, followed by pound, followed by bar. As we actually need to peek ahead in the stream when we encounter a literal pound, which is also going to be a little annoying because I think it's basically going to mean that we have to do... we have to also take the token stream here, which is pretty awkward. Yeah. Do you need to find a way to stay using parse stream? Yeah, you're right. You might be right. So in Sin, where's our parse? The recommendation here was, is there a way that we can keep using parse buffer instead? Because parse buffer already has like look ahead methods and such. Because if so, what we could do here... Yeah, so instead of parsing this as a token stream, just have this can be a sin parse buffer. Although I don't think that will work either because this has to be tied to a lifetime. Although maybe it's a... Yeah. My guess is this parse buffer is tied to the lifetime of the input, which is kind of awkward. Maybe the way to do this is really not parse the braces here. Well, or rather do this, right? But then still keep this as TT as input. That won't work either. Actually, here's what we might be able to do. We might be able to turn the token stream back into a parse buffer for the purposes of expansion. That might really be what we want to do. So down here, when we're given the stream, we're going to do this, right? We make a new one of these. Oh, I can't make a new one of these, can I? So this is going to be a sin parse buffer. And it's going to be stream parse. And then actually, why do I see? It's a little bit awkward. How are we going to do this? So for parse buffer, into a something parse actually. Oh, does it implement just from? No, I don't think there's an impl from here. I mean, unless I'm missing something here, but I don't think there's a from. Syn parse to. Well, okay, what does... let's take a step back here. What are the functions that I get here? Parse tokens of a source code. No. Parse a proc macro token stream into something. Parses a token stream when in a procedural marking. I see, that gives me a T, but what is a parse? Is this implemented for like parse buffer? No. I would have to know what type to parse it into, which I don't. Yeah, I don't think I can use this because I don't have it's not clear to me that I want to parse it as anything in particular is the awkward part. Like I basically don't want to write implements of parse because I would have to parse every possible item because you never know where the end is going to appear. So I would actually rather walk it as a token stream. And I think from memory, doesn't token stream also have a peak? Where's token stream here? I see. I mean, it has a clone. It has clone and into iterator, which is still kind of awkward. Yeah, no, I think I want to keep it. I think I want to keep it token stream, and then really just do. Yeah, here's what I want to do. It's a good question. What is being coded? We're doing the second part of the procedural macro workshop from Rust LATAM. I recommend you look at the first procedural macro stream that we did a few weeks back if you are just jumping into this now. Chat needs a way to pin something. What were you thinking of pinning? That's kind of awkward because we don't have a good way. I think what we have to do is we have to give expand2 access to the following parts of the stream. So what does the into iterator give me here? It gives me one of these. I see. Oh, the answer to what this is about. Yeah, we should pin that. You're right. Yeah, I might have to clone the stream, which I think is fine. It's just I have to clone it at the current point is where it's awkward. I guess I could clone it just every time I call expand. The recursion is going to be annoying too, though. Because really, this is going to be like rest, right? So if this is rest, then now this is fine because this would have to also give rest and expand. What am I talking about? Oh man, yeah, because no, that's right. Gstream. Yeah, no, that's fine. This only needs rest because it's going to have to walk it there. So all we need to do is find a way to give the rest of the token stream to expand to, I mean. And I think the way we're going to have to do that is definitely pretty awkward. I basically want a way to walk the stream without... Wait, is this clone? If that's clone, that is clone. Okay, so this is far easier, actually. I'm just being silly. So the token stream is going to be stream.intoIter. Here, this is going to be far easier. Where's my... This is token stream into iter. So here, what we're going to do is while some tt is equal to, I guess let mute out is proc macro 2 token stream new while tts.next, then we're going to do out extend self expand to tt and tts.clone. Even that's not going to work because we needed to return how far it walked, I think. Oh, so maybe we just do this. Yeah. Yeah. Okay, this will be good. This will be good. I have faith. So it's gonna do this and the I, and then this is gonna return out. And now this has access to the rest mutably, so it can choose to consume more tokens. And so here, this is gonna be all sorts of funky. So if it's that's fine. It doesn't have to do anything special. Here, if it gets an identifier, it's going to have to peek. And the way it's going to peek is by cloning the iterator. And then... Actually, it's not even if it sees an identifier. It's if it sees a... Oh, no, it is if it sees the identifier. Because where we get into trouble is there are a couple of things we could see, right? We could see foo n bar. We could see foo n. We could also see n bar. No, that can't be the case because identifier can't start with numbers. Okay, great. So you will always see an ident first. And then if... And then I guess what we're going to do is match peak.next, right? If the next thing is a proc macro 2 token tree literal, lit. If the literal is equal to this, then something. Otherwise, if it's not, then we know that what we just got was an identifier that was not followed by a pound. It was followed by something else. And in that case, we don't need to do anything about the identifier. We can just leave it the way it was. So in that case, we can just do this. Which means that we can just do... Yeah. Yeah. Okay, this is good. So now, if we go in here, now we need to sort of search further. So the stuff down here is probably just wrong. 8. So I don't know if I can do this comparison, but it'll be fine regardless. Okay, so at this point, what we've seen, ident followed by pound. So the question is, what follows this? Is the next thing the chosen identifier or the repeat identifier? And so here we're going to do match peak.next. And if that is a proc macro to token tree identifier, ident2, if ident2 is equal to self-ident, right? If that's the case, then we have seen ident pound n. We might want to clean up this a little, but for now I'm just going to leave it this way. Okay, so now the question is what comes next? So match peak.next. If it's none, then we know that we should expand, because it means that the pound n was the last bit in this block. If it's some... actually, should we just always do it in this case? It might immediately be followed by some other identifier, right? So imagine that someone writes like fn foo pound n. I guess it would be this. So it would be a literal open parentheses, or it would be a literal group, actually. No, it would just be a group. But you could also imagine something like const. No, what's I can't actually think of a thing that it would be. Yeah, the question is, in this case, in what case would we not expand the n? I think in this case we always expand the n. The question is, why does the exercise talk about, if you remember back to the exercise also talks about pound n pound. Oh, because it needs to be, because otherwise the n would be n underscore suffix, which we would not recognize as n. I see. So it's specifically if the ident is this, then may need to also consume another pound. You don't have to worry about that, because at the end Rust will still validate your output. You can just transform into a new ident and move on. Yeah, but we do need to consume, if the user wrote another pound after the identifier, we do need to get rid of it, because otherwise it would be invalid syntax. So we need to consume it from our input so that it's marked as consumed, because otherwise Rust would say unexpected token pound, I think. Specifically, because we replicate all the input we get that we don't specifically get rid of, we would just repeat out the pound sign as well, which is not what we want to do. And so I think here we want to do, how do we even do this? Okay, let's leave that for a second. In this case, what we do know is that we need to produce a new identifier. Quote. Actually, quote spanned, I guess. It's going to be the span of ident, and it's going to produce ident I. Oh, and I guess this has to be syn parse 2. Let's just see what it gives us for this. Well, first of all, I did something silly somewhere here. And I also did something silly down here. I probably also did something silly somewhere else, like on 67. What did I do here? Found colon. Oh. Yes. Line 71. Yes, that also means one of those. 96. Yes, indeed. 72. Can't compare literals. Of course it can't. Of course it can't. But this we know would be a pack macro 2 token tree lit stir. Otherwise it couldn't be a pound. That's not true. I'm totally lying. Actually, it would be punctuation. It wouldn't be literal. If the next thing is a punct, and it is a... What is a punct? Great. Punct. If punct is one of these guys. Pound is not literal string. Yeah, that's okay. Yeah. So let's see. Oh, am I really not allowed to compare that? Fine. If punct ascar 76 should say, oops, should say ident. And what else do we have? 79 should say token tree. Right, this we can unwrap, I think. Token tree is not an iterator. Huh? Oh, wait a second. What else does where is my token stream? Token stream implements, yeah, extend token tree. Ah, fine. Iter once. Needs to be an iterator, huh? 76, it's complaining that I moved something. That's fine, I don't particularly care if it doesn't move that. 72, that's fine, this can also be by reference. 81. Huh? That's fine, this can also be a reference. Don't actually need to own any of these. 83. Oh, that's why I wanted to own that. Fine. Not important, probably. Oh, I guess our main needs to look like R4 for this to work out. Let's expand to proc macro panicked. Ooh, unexpected token. Where did it panic, though? Also, why is it? Oh, it's printing that just to be helpful. Okay, let's have it not print that. But where did it panic is what I really want to know. Unwrap. Here maybe? We made invalid syntax. Yep. Pound is not litster. I don't think I'm assuming pound is litster anywhere. Line 80 or something. Yeah, it's here. Doesn't need to be litster. It's saying unexpected token, huh? Macro. Parse 2. Parse 2. Yeah. Macro. Not sure what you mean, Felix. Great. Yeah, so apparently it doesn't like this. It doesn't like trying to parse this ident that we create here. We might just have to create the ident ourselves, which is luckily pretty easy, right? So going back to here, where's our ident? So we can just create this with new, and all we really need to do is give the string in the span. So here we're really just going to do proc macro 2 ident new, and then here we're going to have to construct the string that's going to be the ident, and that of course is just the ident and the I concatenated to one another, and the span is going to be the original ident probably. I think that's the span we want. That way we don't need the unwrap either. And we no longer need quote spend. Line 81. Token tree found ident. Ooh, I see. I think that means I can do this instead. And then I can here do ident is equal to that. I can do this. I could do this, and down here I could just return that. How does it like that? Oh, none of that. Well, that doesn't seem great. Expected one of parentheses or square found pound. Oh, right. We're right. So here, what's happening here is basically we are still emitting the pound symbol, right? Because here we given the iterator, but currently because it's just peeking ahead, it doesn't change the iterator, so it doesn't skip the pound sign when we find it here. And so once we get to this point, we need to do we need to set rest to be equal to peak. How about that? F1, 1 times 2, F2, 2 times 2, F3, 3 times 2. Not bad. Not bad. Not bad at all. We still have this to do, right? Like, it might still be that there's yet another pound, right? So remember the case of foo pound n pound bar. Currently, we would correctly replace this with the integer, but we would not get rid of this pound. And so here, we may need to also consume another pound. And so if, I guess we're going to do peak.next. The problem here is, actually, ooh. We might need to, if we peek ahead, So if we peek ahead and it's not a pound sign, then we don't want to consume that next token. And so this is why here we actually need to take the current peak and store it into rest and then continue operating on peak. But we don't have a way to put something back into an iterator. So in this case, I think really what we want here is this. Only in this case and in no other do we want to do this. Right? If we found anything else, then we don't want to touch we don't want to set rest to be equal to peak again because peak has consumed the next identifier. All right, so let's see how far we get in tests. Is it happy with our test 4? It is happy with our test 4. Excellent. I also really want to get rid of all these match statements. Sadly, I think it's a little tricky. There's work on getting if let to work with and, which would make this a lot nicer. I think in theory we could at least do this a little better by saying peak.next, and do this. And this to this. If that and this to that, then this. And now we can get rid of some of these. Am I missing something? Probably. Yep. That's a little nicer. Let's see that it still works. Great. All right, so progress. Number 5. Repeat section. So far, our macro has repeated the entire loop body. This is not sufficient for some use cases because there are restrictions on the syntactic position the macro invocations can appear in. For example, the Rust grammar would not allow the caller to write that. Oh, I see. You can't call a seek. You can't call a macro here. Right, exactly. Instead, we will implement a way for the caller to designate a specific part of the macro input to be repeated so that anything outside that part does not get repeated. The repeated part will be written surrounded by pound open star. The invocation below should expand to whatever, yeah. Optionally, allow for there to be multiple such sections, although the test suite does not exercise this case. Each of them will need to be repeated according to the same loop bounds. Ooh. Are you planning on a break? What kind of break? A real world break? In what sense? Like during the stream? I wasn't planning on it. I have my water. I'm happy. Okay. Right, so now we're going to have to be able to parse something like this. So this changes the calculus a little because now, this is also funky because it means that we need to figure out whether there are such repeat sections in the macro body before we decide whether to repeat the macro body or not. Interesting. Interesting. Okay, so we're gonna have to walk the input, and if we find a pound followed by a group, right? A punked pound followed by a group, followed by a star. In that case, we want to repeat the body multiple times. And in that case, we don't want to repeat the overall body of the macro. Interesting. So this is now going to have to change. Because I think the way we want to do this is we probably want the I think we want to try to do the inner replication first, and if there is no inner replication, then replicate the outer. I think is going to be the plan. Okay, so in that case, so expand is going to, ooh, interesting. How do we want to do this? The problem is we can't just run the inner and have it like set a Boolean as to whether or not it's expanded something, because if it told us it didn't expand anything, then would it leave? What would it do if it found the repeat identifier that has to be replaced with a number? I guess one way would be to run the expansion in like a mode where it knows not to replace the identifier. Oh, that's kind of cool. So it'll basically be like we could do this in 2 passes actually. The first pass does the inner replacement, and the second would do the outer replacement. So basically what I'm thinking is, first you run a pass that expands any inner iterations, like any inner like pound bracket star, and if they did something, then you just return the resulting stream. If they never made any changes, and they have to not be allowed to expand a pound n. They have to not be allowed to expand the identifier to the number unless it's inside of an internal repetition. Yeah. Okay. This will be easier to explain with code. Okay, how do we want to do this? I think we want to do this by saying expand ident bool. This also means that there's going to have to be, this is going to be expand pass. This is going to be, I need to give these better names. But let's write the outer one first. So imagine that we have this expand that is sort of the overall procedure we're going to follow. And that is going to here do out is self.expand pass stream.clone and false. and then I guess mutated. If mutated, then return out. Otherwise, self expand pass not clone true. So when this variable is, and then let me fill this out. So let mutated is false. This does not have the I. Oh, this is weird. Okay, so I don't know if this is the best way to do this, but the idea here is going to be that expand2, when expand ident is false, is only gonna expand repetitions and nothing else. Interesting. Let me see if I can make this a little bit more explicit. So we're gonna have an enum of like, let's see, mode, which is either gonna be replace ident of, which is gonna be the ident I you're gonna replace it with, or replace sequence. And so it's going to be in one of those modes. So this is going to start with mode expand. What did I say? What did I call it? Replace sequence. Otherwise, it's going to do self dot from self dot to value, oops, a map I span pass mode replace ident I collect. Does this make sense? So it's first going to do a pass where it's not going to replace any identifiers. It's going to write out the tokens and then replace only sequences. If that indeed changed something, then we're just going to assume that we're done. Otherwise, we're going to walk the range and then replace the whole thing with the identifier replaced. This means that, think of this as something like, what if a user writes in 0 to 10, like if they write something like fn x n something, and then they also write fn y n. Don't know why they would write this, but imagine that they wrote something like this. What should this expand to? Right? Because this outer one sort of implies repeat the whole block n times. But this part of the block is saying repeat n times. And so if we did in fact repeat the whole block n times, then what this would end up being is this line n squared times, right? Which is just not what we want it to be. And so I think we're basically going to require that the user give us one or the other. Specifically, if we encounter code like this, the first pass, in which it's only allowed to replace sequences, should emit an error when it hits this, right? That would probably be the best way for us to do this. To say, if you encounter this oh no, we can't even do that. It can't be an error, because then this would be an error. because the first pass is always going to be the same. So, ooh, that's not what I meant. So if you see code like this, what should we do? The first pass is going to replace all of these. I think the user is just going to see this as a compile error, because this is just going to remain #n. Ideally, we would give a slightly better error message, but I think that's okay. So this would actually expand only the innermost one and not the outermost one. And that's basically what this expand pass is doing, right? It's first running a pass with only replacing sequences. And if they did something, then we consider ourselves done. Otherwise, we're going to replace the whole block with every eye. Okay, so let's try that. How well maintainable are proc macros? Well, what do you mean well maintainable? This is not Python. This is Rust, the Rust programming language. It's funny that Rust gets mistaken for Python, though. It's arguably a good thing for Rust. Okay, let's see. So, this first pass is going to do a normal pass the way we did. So I think all of this actually stays the same. We just pass in the mode up here. We also need some way to express mutated. Mutated. So this is going to take rest, mutated, bool, and a mode. If we get a group, we're going to, this is going to use expand balls. What's that even going to do? Pass mode. Yep. If it gets an ident. So in this case, we replace something. So we're just going to set mutated as true. Also, we only want to do this if the mode lets us replace the ident. So if let mode replace ident I is mode, then we do that. Otherwise, we're not allowed to replace this ident, and so it's going to stay what it was. Ident. I guess ident.clone. Not allowed to replace idents in top level pass. In first pass. This is not for a game, no. This is not related to the Rust game. Okay, so that's fine. This is going to have the same restriction where let I is equal to that, then I. Otherwise, return that ident. Also, this doesn't. Why did I even do that? Shouldn't be necessary. Then we're just going to return the ident here. Because technically, we can do this. It's a little less nice, but fine. What? Actually, we could do even better. We could say mode here and then match on it down there. That way we don't need the if let. This needs a comma. Right, so if we're in the replace ident and we find those things, that's all great. So now there's one more bit we need here, which is what happens if we find a if we find a proc macro 2 token tree punct if p dot ascar is equal to pound. Then we need to figure out whether this is a repetition sequence. Right? And now we're going to play the same trick like we did previously, which is basically this. And then we're going to match on peak.next twice, because we need to look at the next two items, right? And if those are a group,